Let's look at some attributes and transformations of the natural log function. Now, the natural log function is the inverse of y equals e to the x. You remember we talked about e being a very special number and occurring in nature. So if I have f of x is e to the x, then the inverse of that is y is equal to the natural log of x. Now, of course, it reflects across a line y equals x and has the same characteristics as other functions, but it is used so often, we use a shorthand notation that log based e of x is just ln of x, or natural log of x. Most of your calculators will have a natural log button as well. The domain is from 0 to infinity, as with all logs. The range is all real numbers. The x-intercept is 0, 1, just like all log numbers. It has no y-intercept, and it has a vertical asymptote at x equal to 0. So if I want to find the maximum minimum over an interval, we do the exact same thing we have been doing from 1 to 2. The natural log of 1 is 0. The natural log of 2 is about 0.693. So on the closed bounded interval, -1 to 2, 0 is your minimum, and 0.693 is your maximum. When we do graphs, when I have a 1/2 out here, this of course is going to be a vertical shrink. So it's going to take and reduce the height of my log graph. This is the same thing as 1/2 natural log of x. It's going to have the same shape and the same vertical asymptote. When I have a negative out here, this is going to be a reflection across the x-axis. And so where this is my original log function, when there's a negative out here, the function is going to go from positive infinity through 0, 1, and it's going to continue on to negative infinity. When I add outside of the parentheses here, natural log of x plus 3, this is going to be a vertical shift up, whereas vertical asymptote stays the same. And of course, when I include x minus c in the parentheses, this is going to be a shift to the right. Now what this is going to do is it's going to shift your vertical asymptote. To find your new vertical asymptote, you take whatever's in your argument, x minus 3, and you set it equal to 0. So x equal 3 is your new vertical asymptote. Make sure you sketch it in and identify it. To find where it crosses this axis, you take what is in the argument, x minus 3, and you set it equal to 1, because I know the natural log of 1 is 0. So when I solve this, add 3 to both sides. All right. What this tells me is the natural log of 4 minus 3 is the natural log of 1, which is 0. So this tells me it's going to cross the axis at x equals 4, y equals 0. So you can sketch that point in and draw your curve.